Hello there. Do you enjoy painting? Well, I do, and it's one of my favorite hobbies. I make a painting probably once every 2 months, and I've been using the same painting palette to do these paintings ever since I started picking it up. Over this amount of time doing this hobby that I love, I was curious on how long I've been using my palette for. I noticed that every 2 months, when I've completed a new painting, 5 new paint splotches on my palette appear. After this, it led me to think that I can find out how old my painting palette is by counting how many groups of 5 splotches I can see, and then multiplying that number by 2, because that's every 2 months. At the end of that, it could give me a good estimate of how old this paint palette really is. So I took the liberty to count all of these paint splotches on my palette 3 different times. Did it 3 times to try and get the most accurate average. I got 48 on the first count. I got 53 on the second, but then I got 51 on the third. So my total average came out to be just above 50, so we're just gonna call it that 50. This number gives me 10 total groups of 5 paint splotches, which works out perfectly for my brain mathematically. It just makes it easy. Knowing that each group of 5 splotches represents 2 months of work, I can multiply my number of groups, which I have 10, by the number of months per group, which I have 2. So this ends up giving me 20 total months of painting using this palette, which is just over a year and a half, which is actually exactly when I started getting into painting. So it's really crazy how that math and calculations work out to give me the exact age of how old this palette is. All this talking about paint splotches and counting them to find out how long I've been painting is actually very similar to how scientists find out how old parts of the moon are. But instead of paint splotches, they count craters. The more craters in a certain area, the older it is. Just like how the more splotches I have, the longer I've been using my palette. So, for example, the lunar highlands, which I'll show you right here. The lunar highlands have tons of craters, while there's darker areas on the moon called the lunar maria, and these have a lot fewer. That's because the highlands are older and have been hit by space rocks for a longer amount of time, while the maria formed later from lava flows that covered up the old craters. So about every 25 million years, an asteroid will hit the surface of the moon, and it causes a crater as big or bigger than the crater Eratosthenes. And that crater is this one right here, right there. Scientists use this and they call it the cratering rate. After counting how many of these, after counting how many of these are in a certain area, you can multiply that number of craters by the cratering rate of 25 million years to get you your total age of this specific area. So doing this for both the lunar maria and the lunar highlands, it will leave you with very different results. Obviously, giving you the difference in age and ultimately the rough age of both landscapes. So I used the end of a pencil to measure the crater Eratosthenes, which is right here. The end fits just right in there, so it gives you a good idea of how to find the other ones. This is the crater used to determine the cratering rate. So using this measurement, I counted each crater of this size or bigger. And after doing some counting of the craters on each side of the moon, so this is both of these, and also from the diagrams that we've used in class, we can see that there's roughly 27 craters, this is on average, on the highland side, and only 2 on the maria side. So, using the measurement from the pencil, and doing our multiplication, we know that the highland side is about 675 million years old, and the maria side is only about 50 million years old. a little bit of subtraction later, and we can confidently say that the Highlands are roughly 625 million years older than that of the lunar Maria areas that we were both shown in class, just these two diagrams. So, in a way, both my paint palette and the moon tell a story over time. Each splotch or crater is like a little timestamp marking the passage of time and the history of what's happened there. So just to clarify and go over how we get the average of how many craters are found on the lunar highlands. Obviously, this can be harder to do than the Maria because there's obviously only 2 craters that we can see that are bigger or the same size as Eratosthenes. So what I like to do is just take something to cover it up and just count as I go down to make sure I've covered everything in each spot that I'm counting, so I'm not double counting or counting the same ones over again. After doing that, the average would be 27, so I can count like 31 one time, 25 one time, 27 another time. But the class average from when we were counting these was 27, and that's how many we get to find out how old that this is. Here I'm here with Caleb, and we're explaining my paint palette and how old it is compared to the moon. So I started using this paint palette a while ago, and I wanted to find out how old it was. And I noticed that every 2 months, 5 new paint splotches would show up on the palette. So I thought that like if I count each group of 5 and multiply that by 2, it should be 2 months. I could get a good estimate of how old this really is. So after counting each group of 5, I got to 10. I counted a few times and got the same average, which works out well. So I multiplied that by 2 months for each group of 5 and got to give me 20. So 20 months total, which is just a little bit above a year and a half, which is exactly when I started using this paint palette last year. So yeah, that's using paint splotches and how many of them I see compared to how often they show up over a course amount of time to find out how old it is overall. So this relates exactly to how the moon works with its craters and how old the moon is. So if you look at these 2 figures, this is the lunar highlands, right? And this has tons of different craters on it. And the lunar Maria has a small amount of craters. So counting craters is how we find out how old the surface of the moon is. Obviously, this has a lot more than this. We use this crater right here, Eratosthenes, as our cratering rate. About every 25 million years, one of these or bigger will hit the surface of the moon. So after counting how many of these craters that are of this size or bigger in a certain area, we can use that and multiply that by the 25 million years to find out how old a certain area is. So on this side, we can only count 2. So this is going to be about 50 million years old. On this side, it was around 27 was the average. So it was like 675 million years old. So that's like, this is so much older than this. And it's just like the same way that we did with the paint splotches. You count how many of those and multiply that by the amount of time that each one of those shows up, and then you get how old each relative spot of the moon is. So yeah, does that everything make sense to you so far?
That makes sense.
Yeah. Okay. Perfect. Yeah. All right. Sweet. So this is a graph that I made on counting craters on the moon. So first we can see the Highlands graph, which is labeled in red, goes all the way to 650 million years and 27 craters. So it just shows you how many more the Highlands have than the Maria. And you look on the blue side, the blue line for the Maria, and only goes to about 50 million years and up to 2 craters. This just shows the difference between the 2 Highlands and Maria landscapes. This, on the other hand, is a graph I made as well of the age of my paint palette. So as you can see, there's only one line, and it just represents the age of the paint palette itself, and it's in blue. You can see on the bottom it's paint splotches, and it goes all the way up to 50, and then on my y-axis it's number of months, and it meets at 20. which is crazy. And we find out that this is 20 months old. So, yes.